So question number 4a. It states that there is a triangular pyramid of base edge 50 mm and the slant edge is 70 mm long, resting on one of its base edge in HP in such a way that the triangular face contained by that base edge is vertical and the resting base edge is inclined to VP by 45 degrees. So this is a 3-stage question, and in the case of projection of solids, you have to remember the resting edge should be taken on right. So let's start the solution. As the given question is given resting on HP, so the true shape of the base is visible from top view, so you'll draw the top view first. Taking a vertical projector here, the distance is not given because I have to take 50 mm here, so let's take 30 mm. Okay, so 30 mm I'm taking it as a distance. Then you have to take the base edge of 50 mm sides here. Then you have to complete it. So you have to take the distance 50 mm in your compass from here. Then you have to draw the arcs, completing the base. Once you have completed this, you have to draw the slant edges. So in order to draw the slant edges, you have to use the bisection method. The distance is easy, it is 50 mm. You can easily take the midpoint. You have to do it for 2 sides. So I'm doing it for these 2 sides. And you have to join them. So once you join this, you can obtain the center, that is the apex in this case, and you have to draw these slant edges from each corner of the base up to the apex. So for our convenience, let us label it. So I'm giving here A, B and C. This is the resting edge B, C, and this is the apex O. Let us take it up. So this will be the axis. Here resting is given on one of the base edge on HP, so neglecting the angle at first, you will have all these 3 base corners on HP. So here it will be corresponding front view A dash, corresponding B dash and C dash. Now there are 3 slant edges here, AO, BO and CO. Out of these 3, only AO will be seen here in true length. The reason is, this is the direction of the observer. From this direction, the slant edge which is perpendicular to it will be seen in true length. You have to take 70 mm in your compass. So I'm taking 70 mm here and keeping on A dash, cutting an arc. Make sure you do it from A dash only. If you take from this point, your first step itself will be wrong. So this completes your front view. This is O dash, that is apex. Now the question says the triangular face contained by resting edge. Resting edge is BC and the triangular face containing that edge is BOC. This face is not inclined, rather it is perpendicular to HP. So you have to draw a vertical line here. This is the resting edge, so these points will still be on XY line. You have to take this distance BO in your compass, cutting an arc. Now the total triangular face BOC is vertical. Using the arc method to complete the remaining diagram. So this is the point A dash. I have not changed the names because the dimension is not changed here. It is same. We just have to redraw it. Now you have to complete the top view by taking the projectors down. This is the point from where you will have A. A is on this line here, so you have to take the projector here. So this is the intersection point. This becomes A1. I'm changing the names because here the shape is going to change. Then B is on this line. Here it is on this vertical line. this is the intersection, becomes B1 here. C is on this point here, and it's on this vertical line, comes C1. O is again on the same line of A, so here it's O1. Now you just have to join it. First the base, A to B, B to C, and C to A. Here, two slant edges have been already overlapped. You just have to draw the third slant edge, A, O. So this completes the second step. The third step states that the base edge BC is not perpendicular to VP, rather it is making an angle of 45 degrees. So I'm just extending this projector, drawing a vertical line here, taking this point, taking an angle of 45 degrees at this point. Now you just have to recreate this at this location. So this remains unchanged. Everything you have to just redraw here, keeping the point, cutting an arc. This is your C1. Dimensions are not changing, so hence the names remains the same. This distance here, so you have to keep it here, drawing one arc. And then this is again the same, so you have to keep it here, cutting it. So this distance A to B and A to C will be same. Let's use the arc method only in order to locate the last point, O. So this is O1. Now you have to take the projectors up. Obviously you have to make this side dark. Now taking the projectors up. So C is already there. Here on XY line it should be C1 dash. Then on this you'll have again on XY line, that is B1 dash. A is not here, it's above. It's here A1, and here it's on this horizontal line. This is the intersection point A1 dash. Let's write this below because you'll have to join it. So I'm writing here C1 dash. So if you are turning it on this way, the base will be visible, so you will have all continuous lines here, no dash lines for the base. Now the apex. O is on this point here. Here it's on this horizontal projector. So this becomes O1 dash. Now the outermost slant edges, that is BO and AO, will be visible, whereas CO is passing through this image, as this is a solid, so you cannot see this edge, so it should be drawn as dash line. Now you have to give the dimensions. It's 50 mm, all three sides. Then there is slant edge. So whatever dimensions are given, we just show the same on our solution. So this is the slant edge, which is 70 mm. The angle here is also given, you can show it. So this angle is phi. This completes the solution.